element, okay, exactly like what we see down here. So we know that this is X, this is Y, and this is Z. Okay. So now we have to sketch the element first. Okay. So we know element I is down here. Right. This is our element I. So I'm going to do a sketch of element I. Okay. So this is our element I. And element I, we know that stress X is going to go through compression. Okay. And because of the shear or the rotation down here is going this way, right? The shear will do this. Okay. This is the one that is following the torque. Okay. And this is the other face. Okay, a little better. So this arrow will follow the torque. Yeah, and the other one will that's how we construct shear stress. Okay. Then from here, we are going to try to label what shear stress is this. Okay, so the intersecting plane is X. So this is shear. The intersecting plane is X. The direction is in the Z. Okay. On the other side, this is shear ZX. The rest of the places have zero stress. Okay. So now this is our transformation. So this is our Z. This will be our X. And this will be our Y. Okay. So then we will try to now orientate. Okay. We will want to orientate this entire structure, right? So that it looks more familiar to us. Okay. So what I'm going to do is I'm going to rotate this element such that this is my Z. Okay. And then this is my X. And over here, this is my Y. So this is what we are more familiar with. Okay. So when I do that, this is how the structure will look like now. Okay. When I do that, I'm going to draw as a simple element now. I'm going to get rid of the curve. Right. So we know that stress X, right, will be coming down this way. And because of how we orientate, so you have to somehow visualize this, right? So we have it's pointing opposite direction. So this is how it looks like. Okay. So this is our wait. Let me see this correct. So X by Y is out there, and when I flip across, yeah, this is correct. Okay. So this is how the orientation will look like. So this is our shear. Shear. This is our horn. I'm having a bit of brain fart down here. So this is our shear ZX, and this is our shear XZ. Okay, shear XZ. The X is pointing up, pointing to. Okay, this is correct. Okay. So now we are going to sketch 3D mold circle. Okay, so now we are going to sketch 3D mold circle. Okay, so we are going to label this as our Z. This will be our X. And this will be our Y. Okay, so I'm now going to sketch 3D mold circle. That's a sketch. So from here, what we know is normal stress in the Z is equal to normal stress in the Y, and these are equal to 0. shear xz is equal to shear zx, and this is negative shear, right? And then we know that shear xy is equal to shear yx is equal to 0. And we also know that shear x yz is equal to shear zy is equal to 0. And we know that the normal stress x is in compression. Okay. So from here, we are going to sketch 3D mold circle. So this is our normal stress. This is our shearing stress. Okay. So this is our normal stress. Shearing stress, element rotate clockwise. Element rotate anti-clockwise. Give me a minute, okay? I got someone on my door.
To give them additional copies, so they wrote results on the same test. Is that okay? So I gave them their initial copies and they just started writing. I forgot, I didn't. Is it okay?
This is okay, but you have to be sure that you know what you're grading.
Yes, I got them all to identify which area was the initial, and I got them to write the date, today's date above where they read.
Okay.
So
Like before reading, they finish early.
Yeah.
Okay.
Sorry for interrupting you.
Nope.
Have a good night.
Right. Oh, I'm so sorry. I have someone on my door. You all can hear me, right? Oh yeah, you can definitely. So from here, we're going to sketch 3D mold circle. Okay. So we know that stress X is in compression. Yeah. So this is our stress X. And we know our stress Y and stress Z is 0. Okay. And then we have our shear. Again, this is just a sketch. Our shear here. And then we have our shear. Right. So on X is going to rotate the element in the counterclockwise direction. So over here, this is our X. Right. And then on our Z is going to rotate in the clockwise direction. And our Y has no stress at all. Right. So from here, we can construct a 3D mold circle. So we know that the first circle belongs to so this is our first circle. So from here, right, you already know which formula to apply already, right? So the first circle over here, so this belongs to our exact plane, right? And then we have the other two circles. So over here, this belongs to our YZ plane. And then the last circle over here. Right. This belongs to our XY plane. Right. So from here, right, we know that this is our stress mean, and this is our stress max, and over here, this I call it our stress A. Okay, so from here, we know that tau max is equal to the absolute value of stress max minus by stress mean divided by 2. Right, we can see that already, yes or no? Right, so because if you look at this circle or the configuration of the 3D Mohs circle, it follows exactly, right? It follows exactly like this one. And you'll see that, right? So you have a stress mean value, you have a stress max value. So we know, right? So we are going to use tau max is equal to this expression over here. Okay, so we are going to use tau max. Okay, so we are going to employ, I'm going to use a new page. So we're going to use let me get my element, because I'm lost without my element. Right, so we know that we are going to use tau max is equal to square root of stress x plus by stress z divided by 2, right, squared, plus by shear xz squared. Okay, and is there anything that's missing? Let me look at the formula again. The 2 has been cancelled out, blah, 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 blah. Okay, we are good to go. Okay, so this is the formula that we will use. And that is why we have to construct 3D Mohs circle for that reason. Okay. Right. So now that is the analysis. The critical part of this problem is the analysis. Okay, the analysis is critical. If you don't know how to do the analysis, okay, that's where the problem comes. When I say analysis, is in terms of you have to identify, right, where the maximum shear stress will occur. Or sorry, which element has the highest loading. Okay, then you go into 3D Mohs circle. By going to 3D Mohs circle by using Tresca or maximum shear stress criteria, then we know that you have a mean value, you have a max value, and then finally you come up with tau max. So our trick now is we have to now find, we know that tau max, right, is equal to 50 times 10 to the power 3 psi. We are given that, right? So that's the maximum shear stress, and this tau max, okay, is based on material property. We know that. Okay. So the next thing we have to find is we have to find what is our stress x. We have to find what is our stress z, and we have to find what is our shear xz. Okay. By the way, we know that normal stress Z is equal to what? 0. We know that. Okay, we know that stress Z. So more or less, now we have to identify what is our stress X. Okay, so we don't know stress X. We don't know shear XZ. Okay, so from here, we're going to find these two values. So once we find these two values, we plug it. So so come back to you. I know it's a pretty long problem. We now want to find the diameter or determine diameter of the shaft. Okay, we don't know what that value is. So that is our end game. Okay, sometimes we forget our end game because the problem is just too big. Right. So I'm going to Okay, so this is our loading condition. Okay, so let's find the formula. So normal stress. Okay, so px or stress x